Good morning, students. So let us solve some problems using Cauchy residue theorem. So we are going to solve some problems. We are going to use Cauchy residue theorem. The first problem goes like this: evaluate the integral 0 to 2 pi d theta 5 plus 4 cos theta. So this is in radial part. Okay, so theta exists. So they have converted into polar coordinates. But we know that z equals e power I theta. We know already. So just differentiating, that will give you dz equals I e power I theta d theta. So d theta equals dz divided by d theta equals dz divided by I e power I theta, which is equal to dz divided by z. Anything? Any doubt? Very simple one. So we are going to convert d theta into dz. We are going to convert d theta into dz. It's simple to integrate. So that's the reason that we are going to convert. So we know that cos theta is there. So cos theta equals e power I theta plus e power minus I theta divided by 2. So we know already this formula. We have discussed earlier. So this gives 1 by 2 e power I theta plus e power minus I theta. So 1 by 2, let it be like this. E power I theta is replaced with z. So z plus 1 by z. So cos theta is replaced with in terms of z now. So this is what I told you, that theta will be written in terms of z. So now this integral becomes, which is equal to 0 to 2 pi d theta. What is d theta? dz divided by iz. So dz divided by iz divided by 5 plus 4 cos theta. So 5 plus 4, instead of cos theta we can substitute 1 by 2 z plus 1 by z. Any doubt? Now I can take this I out. So 1 by I it will become. This z comes down. Okay, is it okay? See, I have taken this I out, so this becomes 1 by I. This z comes down to the denominator. So this becomes dz divided by z. 5 plus 4, I have taken LCM here. Just multiply with 2, 1 by 2. So this becomes z by 2 plus 1 divided by 2z. Then just take LCM now. We are going to take the LCM now. Okay. So this is the term that we have obtained earlier. Now see 5 plus 4, as I said earlier, and z divided by 2 plus 1 by 2z. You are going to take the LCM. It becomes 2z. So 2 will get cancelled. You have z square plus 1 2z. That 2z, this 2z will cancel. You have 1. So z square plus 1 divided by 2z. Just take the LCM. This 4 and 2 will get cancelled. So you have 2 here. This z and this z will get cancelled. Okay. So next term. So before that we can go with again LCM. Okay. Just take LCM. So this 4 and 2 will cancel. You have 2. So 2 in bracket z square plus 1 divided by z. Now take the LCM. That will give you 5z plus, here only 2 exists. Correct. So you have 2z square plus 2 divided by z. This z and this z will cancel. You have 1 by I dz divided by 2z square plus 5z plus 2. So this theta term, integral term, is converted fully into z terms now. See, fully into z terms. It's easy to integrate using Cauchy integral theorem. So we know already. So this theorem goes f of z dz integration over c, that will be always equal to 0. We have already discussed earlier. Okay. So 1 by I f of z dz. So we have converted everything in terms of z now. So now this is 2z square plus 5z plus 2. So we will have to factorize this one. So this is quadratic equation. We will have to factorize. We can't factorize immediately. So we will have to use only this formula. Z equals minus b plus or minus root of b squared minus 4ac by 2a. We have already used earlier in mathematics. Okay. So here in quadratic equation, here a equals 2, b equals 5, c equals 2. Correct. So use this formula. You have b equals 5. So minus 5 plus or minus root of b squared is 25 minus 16 divided by 2 multiplied by 2. Your A is 2. Now 25 minus 16, that will give you 9. So minus 5 plus or minus root 9. Root 9 is 3. So minus 5 plus or minus 3 divided by 4. So one root is minus 5 plus 3 by 4. Another root is minus 5 minus 3 divided by 4. So this is one root. This is another root. We'll have to have two roots because z squared is there. Correct? See, in the earlier we have z squared. So surely there must be two roots. So this is one root. This is another root. Minus 5 plus 3 divided by 4 will give you minus 2 by 4, and this will be minus 8 by 4. So this will be simplified as 1 by 2, minus 1 by 2. This will be as minus 2. So we have now factorized the quadratic equation as z plus 1 by 2, z plus 2. You have to multiply these two, will get you this one. So we have factorized. Is it okay? So we have factorized into z plus 1 by 2 multiplied by z plus 2, which is nothing but your f of z. So f of z equals 1 divided by this one. Okay. So we know Cauchy residue theorem, which says that in the last video lecture we discussed about the Cauchy residue theorem, which says that residue of f of z tends to minus 1 by 2, which is equal to limit z tends to minus 1 by 2 z minus a. Can you remember this one? Can you remember this formula? This is of order. What is this order? Order is 1. So can you remember? So z minus a multiplied by f of z. This is your z minus a. So this becomes z plus 1 by 2. Z plus 1 by 2, 1 divided by this factor. This factor. And this one will be cancelled. So you have now 1 divided by z plus 2. See, 1 divided by z plus 2. When z tends to minus 1 by 2. So now substitute for z. So you have minus 1 by 2 plus 2. So that will give you 1 and a half, 3 by 2. Correct? 2 minus 1 by 2 is 1 and a half. So you have now 3 by 2. So 3 by 2, that you will get the answer as 2 by 3. So residue at z equals minus 1 by 2 equals 2 by 3. You have to similarly go for the other one. You have to go for the other one, which is nothing but z equals minus 2. Earlier we did for z equals minus 1 by 2. So now we will go for z equals minus 1 by 2. Similar formula. What of the order here? Again, order is 1. So we have to use a simple formula. Z minus a f of z. So this becomes z plus 2, 1 divided by z plus 1 by 2, z plus 1 by 2, and this one will cancel. You have z plus 1 by 2. You substitute for z equals minus 2. So you will get minus 2 plus 1 by 2. Again, the answer will be minus 3 by 2. So reverse it, that will give you minus 2 by 3. So earlier we got as 2 by 3. Now we have obtained as minus 2 by 3. You add these two, we will have to get the total residues. The residue says that sigma. Can you remember yesterday we discussed about Cauchy residue theorem plus sigma. We will have to add all the solutions at the poles. So 2 by 3 minus 2 by 3, the answer is 0. Of course, we must get the residue, the Cauchy integral theorem that goes always equal to 0. This also we discussed in 2 video lectures before. We discussed the same thing. There is no 0 here, so only C alone. So there's a mistake here, no 0. Okay. So this is Cauchy integral theorem, which says that the integration within the closed loop will be always equal to 0. So we can prove that it must be 0. So it will be 0. Very simple one. Now we will have to find out the solution. So solution goes like this: 1 by I. Can you remember the 1 by I which we have taken earlier? See? Can you remember? This 1 by I f of z. We have solved only for f of z dz. We should not forget about 1 by I. So we have to include 1 by I. So you will get 1 by I, 2 pi I times any one of the solutions you just take. Just take 2 by 3. So 2 by 3. So that will give you I will cancel, and you will have 2 2s are 4. So 4 pi by 3. So this is the answer. 4 pi by 3 is the answer for this integral. Any doubt? Any doubt? Simple one. Okay. Now we will go for the next problem. 0 to 2 pi d theta divided by 5 minus 4 sin theta. Earlier we calculated for cos theta. Okay, plus 4. that is for cos theta, and this is for sin theta. So you have to go with the conversion in terms of z for cos theta, for sin theta. So now as usual the same procedure, z equals e power I theta, dz equals I e power I theta d theta. So d theta can be written as dz divided by I e power I theta, which is equal to dz divided by Iz. Simple one. Whereas sin theta is written as e power I theta minus e power I theta divided by 2i. What is cos theta? Can you remember the cos theta? E power I theta plus e power minus theta divided by 2. 2, not 2i, simply 2. Okay, so you have to remember certain formulae. So this is your sin theta. So 1 divided by 2i. Instead of e power I theta, you can substitute z as usual. So z minus 1 by z. So now this integral can be written in terms of z as 0 to 2 pi dz. What is d theta? Dz by Iz. So dz divided by Iz. Your pi minus 4 sin theta. Pi minus 4. This is your sin theta. Correct? This is your sin theta. Is it okay? 1 divided by 2i. Z minus 1 by z. Very simple one. So now as usual you will have to take the LCM, multiply this one. Again take the LCM. Okay, you will have to bring this z down and I down. The same procedure we are going to follow. See, I have written the same thing. Now what we have done is just take z out here, 1 by I here. Okay, so now just take the LCM. Okay, it will be given as, here there is a mistake here, it must be 2z squared. It is not z. So there is a mistake here, 2z squared. See here, 2z squared. Z multiplied by z squared minus 1 divided by z. Here 2, just multiply. That will give you 2z and minus z. So minus, this will become plus. So 2z squared plus 2 divided by your I plus zi. Okay, I am going to multiply 2 by I. That's all. I repeat. See here, just take the LCM. So that will give you z squared minus 1 divided by z multiply by 2 by I. So that will give you 2z squared plus 2 divided by, we will have to multiply I. So that will become I. This will become zi. Multiply with minus and will give you, this will become minus, this will become plus. So this is z squared. Now you have again you will have to take the LCM. So multiply with zi. So you will have 5iz minus z I will cancel. You have z is there, so 2z squared. Okay, then this must be your multiply with zi. So zi will cancel. You have only 2. So you have 5iz minus 2z squared. Okay, minus 2z squared plus 2. So this is your z squared. Don't forget, this is your z squared. Okay, so you have 5z minus 2z squared divided by 2 Iz, and this I will cancel, and this z and this z will cancel. You have, this must be your f of z. Okay, this is your f of z. So the roots are, so this is, as I said, this is your quadratic equation, minus 2z squared plus 5z plus 2. So that will be your quadratic equation. Minus 2z squared plus 5z plus 2 is quadratic equation. As usual, you have to use the formula minus b plus or minus root of b squared minus 4ac by 2a. So as usual, you just substitute. You have, instead of b, you substitute 5i. So that will be minus 5i plus or minus root of b squared. B squared is 5i whole squared. Okay, so 5i whole squared. Okay, not 5i squared, it's 5i whole squared minus 4ac divided by 2a. 2 stands for minus 2, so there must be minus 2. So that's a mistake. Okay, we'll see. So minus 5i plus or minus, this become 25. I squared is minus 1. So minus 25 plus 16. So that will give you minus 9. So this is minus 9. Minus 9 can be written as root under root. That can be written as I squared 9. I squared is minus 1. So I can pull one I out. So I root 9. So I root I 3. So 3i. I repeat, minus 25 plus 16 will give you minus 9. minus 9 is replaced with I squared 9. Just take the root. I squared, you pull it out, that will give you I. Root 9 will be 3. So 3i. You will get 3. So 3. There's a minus sign here. See? Okay, minus sign. So as I said, I root 9, so you will have 3i. So 3. So there's a mistake here somewhere. So here minus, here also there is a minus sign. Okay, don't forget here minus sign is there. See, you have minus sign here because 2a is there. So minus sign here, there must be minus sign, and here also you have minus sign. So minus 5i plus 3i minus 4 is one root. Then minus 5i minus 3i divided by minus 4 is another root. So we have two roots. We have found out two roots. So minus 5i plus 3i will give you minus 2i divided by minus 4. Minus minus will get cancelled. You have I by 2. Here you have minus 8i divided by minus 4. Minus minus will cancel. You have 2i. So this is one solution. This is another root. Okay. So this can be quadratic equation can be written as this multiplied by this. You need to. So as usual, z minus I by 2 multiplied by z minus 2i. Okay, as usual. So now we have to use Cauchy residue theorem as usual. So we will go for first z equals 2i first. So z equals 2i. So limit z tends to 2i, z minus 2i multiplied by f of z. F of z is this one. So this one will get cancelled. You will have z tends to 2i, 1 divided by z minus I by 2. Z minus I by 2. So instead of z, you will have to substitute 2i. So 2i minus I by 2. 2i minus I by 2 will give you 4i minus I, which is nothing but 3i by 2. Answer is 2 by 3i. So immediately you can say that the another result would be, just guess, minus 2 divided by 3i. Immediately you can guess. So 2 divided by 3i minus 2 divided by 3i will give you 0. So this is what we will have to get. So let us see. Let us see. Okay. So limit, as usual, we will have to go with another one. Limit z tends to I by 2. Another root z minus I by 2. F of z, that is 1 divided by z minus I by 2. Z minus 2i. This one and this one will cancel. You have 1 divided by z 2i. Instead of z, substitute I by 2. So I by 2 minus 2i will give you minus 4i plus I by 2. That will give you minus 3i. So minus 2 by 3. Now you will have to add 2 by 3 plus minus 2 by 3. So we will have to add these two to get the total residue. 2 pi I times 2 by 3i minus 2 by 3i. It is in bracket. Okay, it is in bracket. So you will get, as usual, you will get 0. Now, as I said earlier, just take any one of the roots. That's why you will get 2 pi I divided by 3i multiplied by 2. So that will give you, this I will cancel. You have 4 pi by 3. So this is the answer. Any doubt? So now we will go for problem 3. Problem 3, evaluate 0 to 2 pi d theta divided by 2 plus cos theta. Okay. Now z equals e power I theta. As usual, the same procedure. dz equals I e power I theta d theta. So d theta, which is equal to dz by I e power I theta, which is equal to dz divided by iz. And we have done the same procedure for problem 1. So cos theta equals e power I theta plus e power minus I theta divided by 2, which is equal to 1 divided by 2 z plus 1 by z. As usual, you will have to substitute for theta here, cos theta and d theta here. You will get dz divided by iz divided by 2 plus, instead of cos theta, you substitute 1 by 2 z plus 1 by z. So first you will have to take the LCM. So that will give you z square plus 1 divided by z. Then multiply by 1 by 2. The same procedure. Multiplied by 1 by 2. So you will have, they have multiplied with 1 by 2 first. Doesn't matter, everything is the same. So here we z by 2 plus 1 by 2 z. Now after that you can take the LCM. So you are going to take the LCM, multiply by 2 z, that will give you 4 z. Here you are going to multiply with 2 z. 2 will get cancelled. You have z alone, so z squared. Here 2 z, that 2 z, this 2 z will cancel. You have 1 alone. Okay, this z and this z will get cancelled. You have 2 can be brought out to the numerator. So you have 2 divided by I, dz divided by 4z plus z square plus 1. So this is your f of z. F of z equal to 1 divided by 4z plus z square plus 1. We can, as usual, we can factorize and do the rest of the things. So 2 divided by I, f of z dz is your Cauchy integral formula. So now we'll have to factorize this one. As usual, we'll have to use the formula z equals minus b plus or minus root of b square minus 4ac by 2a. You substitute. So minus b will be your minus 4 plus or minus b square will be 16 minus 4 divided by 2, which is equal to minus 4. 16 minus 4 is 12. 12 can be written as 4 multiplied by 3. 4 you can pull it out. So that will be 2 root 3. So minus 4 plus or minus 2 root 3 by 2. You can pull 2 out here. So you can pull 2 out here. So that will be minus 2 plus or minus root 3 by 2. That numerator will get cancelled. So that will give you minus 2 plus root 3. Is it okay? So one root is minus 2 plus root 3. The another root will be minus 2 minus root 3. The roots are like this. So we have factorized exactly like this. We will have to use as usual Cauchy residue theorem. So which says that limit z tends to, we will go for first root. So minus 2 plus root 3. Z equals minus 2 plus root 3. This is one factor. Z plus 2 minus root 3. 1 divided by your f of z is this one. And this one will cancel. You have rest of the term. Rest of them I have written like this. Instead of z, you substitute minus 2 plus root 3. So minus 2 plus root 3. This is as usual. 2 plus root 3 is as usual. Minus 2 will get cancelled. Minus 2 and plus 2. Root 3 plus root 3 is nothing but 1 by 2 root 3. Any doubt? The other one will be minus 1. It's very simple. Minus 1 divided by 2 root 3. So you have to add. This will become 0. So we will go for the other root. Z equals minus 2 minus root 3. So limit z tends to minus 2 minus root 3 will give you your f of z. So z plus 2 plus root 3, 1 divided by this factor, and this one will cancel. Rest of the term is this one. So instead of z, you will have to substitute minus 2 minus root 3. So we have substituted minus 2 minus root 3. Okay. This is as usual. Plus 2 minus root 3 is as usual. So now minus 2 and plus 2 will cancel. You have minus 2 root 3. So minus 2 root 3, which can be written as minus 1 divided by 2 root 3. So Cauchy residue theorem says that 2 pi I times sum of all residues. So 1 divided by 2 root 3 minus 1 divided by 2 root 3, answer is 0. So for the solution, 2 pi I times 1 divided by 2 root 3. These 2 and these 2 will cancel. Okay. So you have pi I by root 3. Okay. The answer is pi I by root 3. These 2 and these 2 will cancel. So there's a mistake here. No. It is 2 divided by I. Correct. It is 2 divided. So the answer is pi I divided by root 3 and 2 divided by I. That I will cancel. You will have root pi by 3. Any doubt? 2 pi I you should not forget. See here in the problem 2 pi I. This is 2 pi I. 2 divided by I. 2 divided by I. So that will give you 2 divided by I multiplied by this answer. These 2 and these 2 will cancel. I and I will get cancelled. You have 2 pi divided by root 3. So now we'll go for the last problem. This problem is very, very, very important problem. Okay. So now we are going to prove that. So we are going to prove the answer. Okay. And we are going to use the same procedure. But everything is in terms of A and B, not numerals. Not like pi, 3, not numerals. So it is given as A plus B cos theta. We will have to prove this one. Whether we are going to get the answer or not, we are going to prove this one. Okay. So everything is given as greater than 0. The condition is given as greater than, so no negative numbers. All positive numbers greater than 0. As usual, same procedure we are going to follow. So Z equals e power I theta. Your dz will be I e power I theta d theta. So d theta equals dz divided by I e power I theta, which is equal to dz divided by IZ. Same procedure. So cos theta is given in cos theta. So cos theta can be replaced by 1 by 2 z plus 1 by z. Already we have seen earlier. Okay, so now this integral becomes 0 to 2 pi dz divided by iz, correct? Your d theta is replaced with dz by iz divided by a plus b cos theta. So a plus b cos theta is given by this. So as usual, either you can multiply by 1 by 2 inside, or you just take the LCM, doesn't matter. You both will give you the same answer. So what we have done, so we have as usual 1 by I, you can write this I, pull it out, so 1 by I, that is z, 1 by z. So this is given as 1 by z, 1 by I. Okay, a plus b, we have taken as LCM, z square plus 1 divided by 2ez. Is it okay? Now multiply by b first, then take the LCM. So that will give you bz square plus b, then divided by 2z is there. Then take the LCM, that will give you 2az plus bz square plus b divided by 2. So this becomes 2 divided by I. Any doubt here? Any doubt here? See, multiply this first. So that will give you bz square plus b divided by 2z. And here a is this side. So you have to take the LCM. So multiply by 2z. That will give you 2za plus the same thing, z square plus 1 divided by 2. So these two we have brought it to the numerator. So 2 divided by I, dz divided by 2az plus b square plus b. As usual, we will have to factorize this quadratic equation and using the same procedure. And here a equals b, b equals 2a, and c equals b. So this is your a, this is your b, this is your c. Okay, so we are going to use the same formula. A equals b, b equals 2a, and c equals b. So z equals minus 2a plus or minus root of b square minus 4ac. B squared is 2a, so 4a squared minus 4ac. 4ac is 4b multiplied by b, so minus 4b squared. Any doubt? Divided by 2b. So you pull 4 out, so that will give you 4. You pull 2 out, that will give you 2. Simple one. Again, this 2 and this 2 and this 2 will get cancelled. You pull 2 out. These 2, you pull 2 out. So that will give you 2 minus a plus or minus root of a square minus b square divided by 2b. These 2 and these 2 will get cancelled. Okay, so you have one root here. With a minus sign, you will have another root. Plus or minus is there. Plus is for this root. Minus is for this root. So now, what we are going to do is, we are going to write this as z minus alpha, z minus beta. It's correct. This is your alpha. This is your beta. So this quadratic equation can be written as z minus alpha. This is what we have written earlier. See, earlier it was in terms of numbers like minus 1 by 2. So this is 2. So easily you can write z minus 1 by 2, z plus 2, which is equal to 0. But here it is, everything is in terms of letters. So we have simplified. This is for alpha, this is for beta. So this is z minus alpha, this is z minus beta, which is equal to 0. Okay. Now, as usual, the same residue theorem, which goes like this: z equals alpha, the first one. Both will have the same order. So here also order is 1. Here also order is 1. So z equal to alpha is first one. So we will go with z equal to alpha first. Limit z tends to alpha, z minus alpha multiplied by f of z. So 1 divided by z minus alpha, z minus beta. Z minus alpha, alpha will cancel. You have z minus beta. What is z? Z is nothing but your alpha. So 1 divided by alpha minus beta. Okay. So first we will solve 1 divided by alpha minus beta. 1 divided by, you substitute for alpha, you substitute for beta. Simple. Okay. Now b is common in the denominator, so no problem. You have to add the numerator. That's all. So 1 divided by, you have minus a plus root of a square minus b square. Minus minus plus will give you plus a. Here you have plus root of a square minus b square. This a and this a will cancel. Okay. This minus a and plus a will get cancelled. You have this b should be brought up to the numerator. So b divided by root of a square minus b square plus root of a square minus b square will give you b divided by 2 times root of a square minus b square. So this is one root. Okay, we will go for another root, same thing. Now this time z equals beta. So limit z tends to beta, z minus beta multiplied by f of z 1 divided by z minus alpha, z minus beta. This time this one will cancel, you have 1 divided by z minus alpha. Substitute for z as beta, so beta minus alpha. So 1 divided by beta minus alpha will give you 1 divided by, this is for your beta and this is for your alpha. So as usual b is the same, common, so you can write b and just add these two. So that will give you minus a minus root of a squared minus b squared plus a minus root of a squared minus b squared. So minus a and plus a will cancel 2 times with the minus sign. So 2 times with the minus sign. Any doubt on the slide? Simple one. Minus b divided by 2 root of a squared minus b squared. Now add these two. Surely it must be equal to 0. Cos, as usual, cos is integral theorem, integral formula, that will be equal to 0. So as usual, the integral goes 2 divided by I multiplied by 2 pi I multiplied by any one of them. So b divided by 2 root of a squared minus b squared. Okay, so I will get cancelled. Then your 2 will get cancelled. You have 2 pi multiplied by this b and this b will get, b is outside, will get cancelled. You have 2 pi divided by root of a squared minus b squared. So this is what the problem goes. In the problem it is given as 2 pi divided by root of a squared minus b squared. So that's all. So thus we have proved the given one. Okay, any doubt? So we have solved 4 problems. This is of the same type. Any one of the problems surely will appear for the examination. Especially last problem is very, very important. Okay, we have proved. We have evaluated all the integrals for in terms of cos theta, sin theta. That will be written in terms of z, and you can solve using Cauchy residue theorem. Okay.